Hey guys, okay, we're going to learn the sine and cosine today, those ratios. Last class we learned that the tangent of an angle is a ratio. In the numerator we have the length of the opposite leg. In the denominator we have the length of the adjacent leg. Today we're going to do sine and cosine. Okay, we still always have to go from an acute angle. You always have to go from acute angle. Okay, the sine of the angle, right? We put SIN, but we read it sine of angle A, the sine of A, sine of angle A. That's how we say it. The sine is equal to the length of the opposite leg from A. It's always from this angle divided by the hypotenuse. Notice before, the length of the opposite leg over the adjacent leg, that's tangent. That's what tangent means. That's how it's defined. Sine is defined by the length of the opposite leg over the length of the hypotenuse. So I'm putting OL in H, and it's always from A. Okay? I'm going to rewrite it real nice and neat. The sine of an angle equals opposite leg over hypotenuse. There it is, right and concise. If you need more words, you're going to look up here to see it. Okay, so let's write a ratio right now. We're going to put A, N, T. Make your right angle at N. And I want you to write the ratio for each of these. Okay, just write the ratio. Number one, what is the sine of angle A? What is the sine of angle A? So I'm going to circle A to help me see it. From A, I know that my ratio is opposite leg over hypotenuse. So I've got to do the opposite leg from A. This is opposite. You go across to the other side, right? It's going to be this one. That's going to be my opposite leg. And then I'm going to use my hypotenuse. Hypotenuse is always across from the right angle. Let's put some numbers on here to help us get going. And I'll put, let's see if this shows up. I'll put 3, 4, and 5. Okay? So we're good? So this is we said across from A, opposite leg. Across from the 90 is my hypotenuse. That's all I'm using. So I'm going to go the sine of the angle, opposite leg over hypotenuse, right? My opposite leg is 4 long, and my hypotenuse is 5 long. So that's it. The sine of A is 4 over 5. If I do that as a decimal, I divide 4 divided by 5, which is also 0.8. I could do both. Both are correct. Number 2, let's find the sine of T. So instead of going from A, right, I'm going from a different angle, so my names change. Hypotenuse is a hypotenuse. That one doesn't change. But I'm not going from A any longer. I'm going from T. So from T, the opposite leg is 3. Okay? So I'm going to go 3 over 5. Okay, and if you divide that, that's 0.6. That's it. Okay, now let's do a harder problem. That's just writing, no, let's just do that right now. And let's do cosine. Same thing, we're going from an acute angle. Cosine, instead of the opposite leg, it's going to be the length of the adjacent leg to angle A, right? Okay, divided by the hypotenuse. And we're going to call this adjacent leg over hypotenuse. We say this, we're going to read it as cosine of angle A. Cosine of angle A. We should probably put of. cosine of angle A. I'm going to write it in the beginning. Cosine of an angle, because the angle always goes here, equals adjacent leg over hypotenuse. Okay. So I've got tangent up here if I need it today, sine, and cosine. Okay, let's do another problem. Let's use ant again, and I also write those steps with it. A, N, T, right? We're going to write the ratios. And let's do cosine. Let's still do 3, 4, and 5. That's an easy Pythagorean triple. And let's do, want to do one, the cosine of angle T. Okay? Cosine's adjacent leg over hypotenuse. So we're going to do, for both of these, right? We always circle the angle, right? Number 2, label the sides, okay, for that ratio. Might help if you just do those sides, okay, and then write the equation. Okay, those are our steps. We're going to circle the angle, so I'm going to circle, I'm saying the cosine of t, so I'm circling my t. Label the sides. I know I'm doing cosine, so for cosine it's going to be adjacent leg over hypotenuse. So from t, if I go across, that's my opposite leg, right? I don't need opposite leg right now. That means this leg that's next to part of angle t, this is my adjacent leg. 4 is my adjacent leg. So 5 is my hypotenuse. The hypotenuse is always across from opposite to the 90-degree angle. So on this one, you're just filling it in. So my adjacent leg right here is 4 long. And my hypotenuse length is 5. So it's just equal to 4 over 5. So you can read it. If you're to divide it with a calculator, right, that's 0.8. You guys, if you pay attention, you're going to see some patterns here. Number 2, let's do the cosine of A. So this time I'm not going from T. So the name of my sides change because I'm not going from T. So I'm going to erase this so I can see it. Sorry, my eraser stinks on this. Okay, I am going from, oh, sure it gets blurry, A. From A. Okay, so we're doing adjacent. 4 is opposite, it's across. 3 is my adjacent, that's my adjacent leg. That's still my hypotenuse. So when I do cosine, right, we're doing adjacent leg over hypotenuse. We said my adjacent leg to A is 3. My hypotenuse is 5. So we've got cosine is equal, I'm going to rewrite it so you can see it, 3 over 5. If you divide that, it's 0.6. Okay, so go down to the bottom. Let's do some of these. And I messed up. My triangle is R, S, T, and I did all Z's on this. So let's just change these to R's. Okay, so we want the sine of angle R. So I'm going from R. I'm going to write in here to help me on this. Sine is equal to opposite leg over hypotenuse. So from R, okay, box points to the legs, the opposite leg, right, and my hypotenuse. This is my adjacent leg. You only have 2 legs. Across from is opposite leg. This leg's adjacent leg, that's the hypotenuse. So the sine of angle R is 16 over 65. And then I could also divide. What is 16 divided by 65? And get that answer here. Because I want the decimal and the fraction. The cosine of angle R, well, that's equal to the adjacent leg over the hypotenuse, right? So that one, my adjacent leg is 63. My hypotenuse is 65. So we get 63 over 65. And then my tangent of R, right? Opposite leg over adjacent leg. 16 over 63. Opposite leg over adjacent, opposite leg over adjacent leg. 16 over 63. Okay, you have a question just like that on your test. So make sure you can do that and you understand. Okay, so on these, you're just finding the sine of x, right? Then you're going to find the cosine of z. As you do these, watch for some patterns. Okay, now, before I keep going, I want to go do a harder problem where we're writing the equation and solving for x. So we're going to do that first. Write the equation and solve for x. So let's on this one do triangle dog. This one's harder, especially if you're not told which equation to use. For right now, though, we're going to just go in order. I'm going to tell you that this is 16 degrees. Angle G is 16 degrees. I'm going to tell you the length from D to O is 5, and the length of my hypotenuse is x. So I'm going to do the harder algebra first with the x in the denominator. So first thing I'm going to do is circle the angle, right? Circle the angle with a measurement. We're always going to do that first. Okay? And then label the sides that have information, whether it be an X or a number. We're going to label the sides, and we're always doing it from this angle, right? We're going from this angle, G. I meant to get the G too, sorry. Label the sides with information. Don't label the sides that has nothing, because it's not helpful. Okay, so if I look here, O to G, I've got nothing on this side for a length. Nothing's there. So I'm not going to write anything. I'm not going to label that side. This side has an X. So I'm going to label that side. That's called my hypotenuse because it's across from opposite to their 90-degree angle. This side here I'm also going to label because there's a 5 there. So I go across from the 16 to the 5. When I'm going across, that's called the opposite, and I know these, it's a leg because the box points to it. So this side's an opposite leg. Now, I know we're doing sines, but I'm also showing you how you can determine that it's a sine function. If I'm using opposite leg and hypotenuse, that is the sine function, because that'll hit some of our problems later. Number 3, or sine ratio. Determine which trig ratio to use. Okay, in this case, opposite leg, right? We've got opposite leg, hypotenuse. Opposite leg and hypotenuse is sine. So I'm going to write the sine. So then 4, write the equation. Remember, we talked about scaffolds. This is a scaffold, a support to help you get it done. If you do each step, you can do this. Okay, the sine of angle G, you put the measurement of the angle equals the length of the opposite leg over the length of the hypotenuse. Now, this is a hard kind because x is in the denominator. So I'm going to multiply. I cannot just go divide by 5 to get rid of it. I have to multiply each side by x to move the x to the numerator. So I'm going to get x times the sine of 16 equals a 5. Then I'm going to divide each side by the sine of 16. So x equals 5 divided by the sine of 16. Okay, so let's punch it on our calculators and see what we get. Clear? So I'm going 5, right, divided by sine 16. You could close a parentheses or not, doesn't matter, equals 18.1. Okay? Now this side, it's only a 16-degree angle. It's not open much. It's pretty short. It's 5. but this is 90, and we're saying that side is 18. That'll work for me. That makes sense. Okay, let's do a cosine problem, and then we'll practice some, and we're done, okay? So, bell's going to ring in a second. You'll hear it, sorry. DOG. Okay. This time, I'll do the kind, let's make this one to 10. The length from D to G is 10. And the length from O to G, let's say, is X. Okay? And we'll say this is 16 again, just for snicks. That's 16. 16 degrees. Okay, we're going to do the same thing that we did before. Circle the angle with the measurement. So I'm going to circle this angle. Okay? Label the sides with information. So X has information. This is my opposite leg. This one, X, is my adjacent leg. Across from the right angle is your hypotenuse. So I've got hypotenuse and adjacent leg. So we circled the angle with the measurement, we labeled the sides with information. Which trig ratio do we use? So I've got adjacent leg and a hypotenuse. If I look at this, opposite leg, adjacent leg, opposite leg, hypotenuse, adjacent leg, hypotenuse, I'm using cosine. So it says write the equation. I'm going to write the equation and solve it. So on this one, I'm going to have the cosine of 16. It's always a cosine of the angle, right? So you put the measurement of the angle in there if you know it, equals the length of the adjacent leg over the length of the hypotenuse. Now this time the x is in the numerator. The x is not by itself, so I have to get rid of the 10. The inverse operation of division is multiplication. I think it's easier to write the 10 in front with a calculator. 10 divided by 10 cancels as 1. I've got x equals, so let's do this on the calculator. Oops, clear. I'm going to go 10 times cosine. This time we're putting the measurement 16. Okay? If you didn't put the 10 first, you would have to be sure to close the parentheses and then go times 10. Otherwise, it's going to go 16 times 10. It's going to take the cosine of 160. It's a problem. So hit enter. And you're going to get x equals 9.6. Okay. That's good? Okay. Angle of depression. This one I want to talk about real quick is the angle formed by horizontal line, just like we did before. Instead of looking up, to depress is to go down, and line of sight down. Okay, we'll do a couple problems. I'll leave them on the board. We'll see what we got. Thanks, you guys.